The final thing we're going to look at in Chapter 19 are polymers. Polymers are long molecules made of repeating units, a smaller unit called a monomer. Sometimes those monomers are identical all the way through, sometimes they come in a variety. So we have natural polymers, things that exist in nature that are polymers. An example would be DNA. DNA is a very long chain of repeating units and is a polymer built by our body. Proteins can often be polymers. They're made of smaller monomers called amino acids, and they connect up to make a whole variety of molecules. Cellulose, which is your strong material found in wood and plants, is also an example of a polymer. It's made from chains of sugars, and your carbohydrates are also chains of sugars, just connected a little differently than cellulose. The polymers are made in a variety of ways, so we're going to go over some of the possible classifications of polymers, usually based on what they contain or how they are created. The first is an addition polymer. An addition polymer is a compound that has a double bond in it in the monomer, and that double bond breaks, which allows the carbon or the nitrogen, usually the carbon that's there, to now have a bond that's available to form a new bond to the next monomer unit. So when you have those double bonds break, those electrons then bond to each other in single bonds to the next monomer, and you make these long chains. Some examples of addition polymers would be polypropylene and polystyrene. You've probably heard of polystyrene cups. Polyvinyl chloride. Those are all addition polymers. We've got a double bond, it breaks, it joins to the next monomer. Condensation polymers are another really frequent type of polymer. These ones, as the monomers join together, you lose a small molecule that comes out so that you've got electrons there to form your new bond in the chain. So one of the most common small molecules that will come out is water. You'll lose an OH from one monomer and an H from another. They form water, and from where they left, those two bonds then join together, and that just keeps repeating until you get a long chain. They have to have a functional group on them that has that OH or whatever it is they're going to lose in order to actually be effective in forming a condensation polymer. So nylon is a condensation polymer. Polyethylene terephthalate is also a condensation polymer. You'll usually see that one written as PET. And those form by losing a small molecule. Then we have our addition polymers and how they can form. So we could take a copolymer, which is made of two types of monomers that actually alternate. So instead of being the same monomer over and over, A, they're made A, B, A, B, A, B, and they just keep alternating like that. They also have thermoset polymers. These interlock and give you a very rigid plastic when they're done. They're very strong and durable. But once you heat them and let those polymers reset, they tend to not be able to be heated and reset again. So it's a one-time forming sort of thing. So examples would be Formica countertops, Melmac dishes, or Bakelite. These are kind of older ones. The Bakelite was particularly brittle once you've thermoset it to the shape you need it to be.